Greetings, gang. Welcome back. How you doing? Hope you're still breathing, hanging on. Lecture number 27. We're continuing with organic chemistry. Lecture number 2. We're going to continue with the alkanes, A-N-E. Okay, so alkanes continued. Remember, everything's going to have an A-N-E ending. Alkanes have this formula CnH2n plus 2. Alkanes are all single bonded carbons, only single bonds, okay? What is CnH2n plus 2? Let's remember what that means. It means if I have n carbons, I have 2 times that number plus 2 hydrogens. We're doing hydrocarbons right now. So let's look at heptane. Remember hept is 7, heptane. Hept is 7 carbons, so if I have 7 carbons, 2 times 7, 14, plus 2, 16. Octane, stuff in gasoline, right? Octane, oct is 8. If we have 8 carbons, 2 times 8, 16, plus 2, 18. Butane, M-E-P-B, me eat peanut butter. B is 4 carbons, butane, so 2 times 4 is 8, plus 2 is 10. Butane, okay? Butane's the stuff in the lighters. All right, and again, we have these prefixes, and what we're going to need to do when we do these problems is, first thing is to find the longest chain of carbon atoms. Actually, the first thing we need to do is to see if there's any single, double, or triple bonds, because that will tell us the ending of the compound. Here we're just doing alkanes, so everything we do with single bonds ends in A-N-E. If you would get a problem on an exam and you see, I say, what's the name of this compound? And you see a double bond, if there's a double bond in there, the ending cannot be A-N-E. If all the bonds are single bonds, the ending is A-N-E, okay? So, all right, let's look at hexane. Hex is the prefix for 6, okay? 6. So let's count. 1, 2, 3, 4, 5, 6. Okay, 6 carbons. And so there's 2 times 6 plus 2 should be 14. So this should be C6H14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so there's the formula for hexane. Now what I want to do is I want to make a single substitution and tell you the rules. And do this by example. So for, just say I'm going to take this hydrogen and I'm going to replace it with a bromine. Okay, I'm going to put a bromine, one of the halogens. Okay, this molecule, it's still hexane. The longest chain is still 6 of carbon atoms and there's only single bonds. But now it's modified. It's modified by this bromine. So I need to tell you about this. So I'm going to call it 1-bromohexane. Why 1-bromo? Well, the answer is because it's on the first carbon. Watch this. Watch this. If I put an H there, and on the second carbon, if I put a Br, can you guess what the name of this would be, really? So, this would be 2-bromo. Oops. 2-bromohexane. And you say, so who cares? What's the difference? All right, well, I'm going to tell you something about organic chemistry. I'm going to make something up completely random, but I want to make a point. Suppose I had a bromine in this hexane on the second carbon, 2-bromohexane. This compound could be, again, I'm making this up, a black poisonous gas, okay, that just will kill you instantly. Suppose I had the bromine and made it 1-bromohexane. Okay. Well, that compound could be completely different. It could be a pink sweetener for candy. Okay. Same compound in the fact that it has 1-bromo and it's with hexane. It has a single bromo with hexane, but where the bromine is completely changes the molecule. It can make it poisonous or non-poisonous, can make it a solid, can make it a gas. So you must say where that bromine is. Okay, because that'll determine what type of molecule. Now, I'm going to erase again, put an H here, and I want you to look, okay? And I'm going to put a bromine here. It doesn't matter where on that carbon, okay? So your initial reaction would be, okay, what's the name of this molecule? Initially, you'd want to say, what? 1, 2, 3, 4, 5, 6. It should be a 6-bromo, right? Yet, no, not a 6-bromo. Why isn't it a 6? Okay, organic chemistry, what you do is you always try to choose the lowest number for the configuration. Now, what does that mean? What are you talking about, Mancini? What is this? All right, I want you to look. Suppose I have hexane. Here's the molecule. It's floating in space. You're looking here. If I have the bromine here, it's clearly on carbon number 1. Okay? What if I had the bromine here? Well, if you go around the molecule, the bromine here would be on carbon number 1. On your side, it looks like carbon 7. To my side, it looks like carbon 1. When the bromine was here, to you, it looks like 1. To me, it looks like 6. Did I say 7? Looks like 6. It's hexane. Okay? So which is right? Is it 1 or is it 6? You always pick the lowest number. So when we start naming these things and counting where substitutions for hydrogen are, you must count one way and count the other way and see which gives a lower number. Let me just show you what I mean real quick. Suppose here I had a bromine, and a bromine. Okay, well, where are the bromines? Well, they're on this side, right? So this would be, I'd call this 1, because it's on carbon 1, 2, there's 1, and there's another one on carbon 2. Does everybody see that? So it would be 1, 2, 2, tri-bromo. Do you see why it's tri-bromo? Because there's 3 bromines, and then that's still hexane. So bromine here, bromine there, bromine there. This would be 1, 2, 2, tribromohexane. You must tell me where the bromines are. Okay? If I started on the other end, bromine, bromine, bromine there, right? That again would be 1, 2, 2, tri-bromo, because now they're on the other side. So if this is my molecule, I have 1, 2, 2 from this side. So this would be 1, 2, 2, not 5, 5, 6. So 1, 2, 2 is a lower number than if I count from left to right, if I counted and made it 5, 5, 6. Okay, does everybody see that? So this would still be 1, 1, 1, 2, 2, not 5, 5, 6. You have to look at it both ways, three-dimensional, and see what gives the lowest number. 1, 1, 2 tribromohexane is a lower number than 5, 5, 6 tribromohexane, okay? All right, so let's keep that in mind. Let's look at this example. I want you to look at this. I put different substitutions. I put bromine, chlorine, and I put fluorine. Now, when we write the molecule, when we write the name, you need to put the substitutions in alphabetical order. So, for example, the Br comes before the Cl, comes before the F. So bromine comes before chlorine, comes before fluorine. So first let's count the longest chain of carbons. 1, 2, 3, 4, 5. So this is definitely a pentane. Okay? Now, where's the bromine? Well, it looks like the bromines are starting on this side. So this would be carbon, I'm going to write this, watch. 1, 2, 3, 4, 5, 6. Oops, it's only 5, sorry. Okay, so there's 5 carbons. So where are the bromines? Let's see. There's a bromine there, 1, 2, 2, and that's it. So we have 1, 2, 2, tri-bromo. 1, carbon 1, 2, 2. Now, what comes next after bromine? Comes chlorine. So where's the chlorine? Well, if that's carbon 1, 2, 3. Here's chlorine. I have a chlorine on 4, another chlorine on 4, and a chlorine on 5. So this would be 4, 4, 5. Once again, there's 3 of them, so now it's trichloro. I'm almost out of breath. Now, let's count the fluorines. Where's the fluorine? The fluorine is on carbon 3, so I put a comma, 3 fluoro. pentane. I've just named this molecule. Wow, isn't that incredible? Look at how smart we are. So this is 1,2,2-tribromo, 4,4,5 trichloro, 3-fluoropentane. Isn't that amazing? Man, that's beautiful. Okay? All right. I want you to name this. I'm going to erase this crap because you have it in the video, so it doesn't matter if I erase. So I want you to take a look at this molecule, if you can see it, and then try to name it, and I'm going to go through it now. First, I'm going to try to count the longest chain of carbons. 1, 2, 3, 4, 5, 6, 7. 7 carbons. The prefix is heptane. I'm just going to write it up here, heptane. Right, that's this molecule. Once again, okay, I put substitutions. Let's see, what do I have? Bromine, chlorine, and fluorine. What the heck, okay? Now, if you'll notice, I put the bromines here. If I start on this side, right, it's heptane. Where's the bromine? It would be 1, 2, 3. It would be 4, 6, 7, 7. 4, 6, 7, 7. If I start counting from left to right, this is carbon 1, 2, 3, 4, 5, 6. If I count from left to right, I would have 4, 6, 7, 7 tetra, because there's 4 bromo. Tetra is 4, and there's 4 bromines. Okay, but that's not right, because if I count from this end, going this way, this is carbon 1, 2, 3, 4, 5, 6. If I count right to left, let's see. Well, now I have 2 carbons there, two bromines on the first carbon. So it would be 1, 1, right? 1, 1. There's a bromine on 2. Okay, and where's the next bromine? 3. There's a bromine on 4. And again, this is tetra bromo. 1, 1, 2, 4, tetra bromo. Okay, so now we're counting right to left. You can't now switch and count left to right. This is the way we're counting, right to left. Now, what comes next? Oh, chlorine comes next. Where's chlorine? Is a chlorine on 1? Where else is there a chlorine? 1, 2. On 3 is a chlorine. See, there's 3 chlorine. Any other chlorines? 6 is a chlorine. There's 3. If I didn't miss anything, there's 3 chlorines. So this would be trichloro. It's good. Trichloro, because there's 3. Now we do the fluorine. Where's the fluorine? Again, none on carbon 1, none on carbon 2. On carbon 3 is a fluorine. On carbon 4 is a chlorine. So I have, what did I say? 3, 4, 3, 4. Look, on carbon 5, there's 2 fluorines. So I got to tell you that. 5, 5. So there's fluorines. So there's a total of 4 fluorines. So why do you say 4? You say tetra. So this would be 3, 4, 5, 5 tetra fluoro. And we said the whole molecule was 1, 2, 3, 7 heptane, right? How amazing is that? So let's say this slowly. Let's just appreciate what we just said and what we just figured out. You see, you can figure this out. It's not that bad. It's just, you know, counting and alphabetizing and not so bad. Okay, so let's see. So we just named 1124 tetra bromo, 136 trichloro, 3455 tetrafluoroheptane. Geez, that's impressive. Isn't that great? That's just amazing. All right, so that's the name of this molecule. All right. Good. I want to tell you about something now because we're going to do other substitutions. We're going to do things called alkyls. Alkyls. So I want to focus on alkyls and tell you about alkyls. So let's look first. Remember, methane was CH4. Okay, CH4. Can you see that? All right. Methane is CH4. Carbon is very happy because all 4 bonds have a hydrogen. If you take away one hydrogen, now you have not CH4, but you have CH3. And so you have a free bond. Now it wants to bond with something. So we took an alkane and we took one hydrogen away. Let's look at the next one. Me peanut butter, Me. E is ethane. Ethane has 2 carbons, so it's C2H6. 2 times 2 plus 2 is 6. C2H6. Again, take a hydrogen away, doesn't matter where. We have C2H5. Notice it's an odd number. It's an odd number. Free bond again. Okay? So it's not ethane anymore. Okay? Let's look at the next one. Propane, 3 carbons. 3 carbons, C3H8, 2 times 3 is 6, plus 2 is 8. So there's propane. Once again, take a hydrogen away, and now we have C3H7. Okay? So what we have, if we look at CH3, if we look at C2H5, if we look at C3H7, notice the second number is odd. And what we're doing, remember the alkanes was CnH2n plus 2, alkanes. Now we have CnH2n plus 1, and these are called alkyls. So what does that mean? It means the ending is -yle. 1 carbon, the prefix is still meth. So what is CH3? This is methyl. C2, this is ethyl. C3, right? C3 was propyl, like propyl alcohol. 4, MEPB. So C4H, can you figure this out for an alkyl? So here I want butyl. So if I follow this formula, N is 4, right? 2 times 4 is 8, plus 1 is 9. So that's butyl. What do you think pentyl is? Can you guess? Pentyl is 5. So C5, 2 times 5 is 10, plus 1 is H11. What about octyl? Octyl, okay? Well, that's C8H. 2 times 8 is 16, plus 1 is 17. Okay? So the yle groups have this formula 2n plus 1. Now what are we doing with this? What are we doing with all this crap? Well, I'm just going to use those as substitution. So we'll do an easy one. So, 4 carbons is going to be my longest chain. What is that? MEPB. This is butane. Okay, this is definitely butane. Now I'm going to put some stuff here. So what do we have here? Well, CH3, if you remember, is methyl. F is fluorine. What comes first, fluorine or methyl? Fluorine, right? So we're going to start at this end because this is going to give us 1, 1, 1, carbon 1. So this is going to be 1, 1, 1, trifluoro. So this is carbon 1, carbon 2, and on carbon 3, we have a methyl. So we have 3 methyl. So this molecule is 1,1,1 trifluoro 3 methyl butane. Okay? I want you to see something. I want you to notice this. Does everybody see there's a C here, H, H, H? So this is really a CH3 also. Okay? Now, I counted this is my longest chain. I could have counted this is my longest chain. Go to this carbon. But it's exactly the same. This way or this way, it's exactly the same. So if I do my longest chain this way, it's still butane. And on carbon 3 is still a methyl. Okay? So if you count the carbon, that carbon is part of your longest chain, it's not an addition. So if this is my chain, this is my addition. If this is my chain, then this methyl was my addition. Doesn't matter in this case. Okay, so let me do one more little example here. Okay, so this is going to be my longest chain, maybe. 1, 2, 3, 4, 5, 6. 6 is hexane. Okay, so I'm going to put some stuff here. And again, top or bottom doesn't matter. Okay, you still end up the same. So let's look at this crazy thing. Can you see that? Can you see? I know the board is getting dirty. So the longest chain looks like 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this is 6 carbons. That's hexane. So it's definitely hexane. And what do we have? We have bromine, we have chlorine, and CH3. Remember, CH3 is methyl. So bromine, chlorine, and then methyl alphabetically. So let's name this. I think, looks like we need to start from this side. This will give us a lower number than starting left to right. You'll get used to this. So I'm going to call this carbon 1, carbon 2. You don't have to write it, but I'm going to write it because I'm not that bright. 4 and 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, oops, 4, 5, 6. My math isn't so good. Okay, so let's see. So we're going to start with the first addition should be bromine because B comes before the others. So where's the bromine? Looks like 2, 2, right? So we have 2, 2, dibromo. Does everybody understand why it's dibromo? Right? There's 2 of them. Next, after bromine comes chlorine. So let's look. We have 1, 1, 1. They're all on carbon 1. And a chlorine on 6. So we have 1, 1, 1, 6. What is 4? 4 is tetrachloro. And then we finish with methyl. Where's the methyl? It's on carbon 4, 2 methyl. So we have 4, 4 dimethyl. Is that a mouthful or what? So this compound, what I drew, what I made up was 2, 2 dibromo, 1, 1, 1, 6 tetrachloro, 4, 4 dimethyl hexane. Man, that's easy. That's easy stuff, right? That's not too bad. Now, throw your curveball, okay? Of course, of course. Remember, always count the longest chain. All right. Let's see what we can make up here. Wow, can you see this? This is crazy. All right, so it's a tricky one. So turn off, stop the video, and see if you can name this. And let's see who can get this right. Let's see if I can get it right, okay? So what's the first thing we need to do? Well, there's 2 things. One thing we always do is we look for the single bonds. That tells it's an alkane. And then we find the longest chain. So, because you're new at this, let's find the longest chain. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. See, I'm following the carbons. So what's the longest chain? 1, 2, 3, 4. MEPB. It's butane, right? No. Longest chain. You see the C5? C5 means there's 5 carbons. I'll write it out in 1 second. You don't have to write it out, but I'm going to write it out. I just want you to see. So that's 5, 6, 7, 8. This molecule is octane. Octane. The longest chain is 8. I'm going to do it again. 5, 6, 7, 8. 5, 6, 7. 5, 6, 7, 8. 5, 6, 7, 8. So we're going to keep this as our longest chain because we don't know how to add things with fluorines. Okay, so let's see. I'm going to take the C5H11 and do this. Instead of C5, I'm going to put 5 C's. There's 1, 2, 3, 4, 5. Okay? What is C5H11? Well, it looks like pentyl. Right? It's only pentyl if it's an addition. Okay? It's not an addition. I'll tell you what I mean by an addition in a second. So, my longest chain is this. This is going to be my longest chain. I'm going to darken it. If you have colored pens, it works much better than this. Colored pens to draw the longest chain. The longest chain is octane. Anything not part of the chain, listen to me, anything not part of the chain is an addition. That's the stuff you're going to add to the octane. Okay? That's why I didn't do 1, 2, 3, 4, 5, 6, 7. I could have gone up to here for 8. But then I'd have this addition, and I don't know how to name that because we can't do those fancy things. So we're going to put that carbon as part of the chain, and so this is not part of the chain. Everybody watch. This is not part of the chain, and this beast is not part of the chain. What is this beast? That's just CH3. So that's a methyl. This is methyl. This is methyl. And that's fluorine. So where should I start? If I start here, 1, 2, 3, 4, 5, 6, 7, it would be 8, 8 difluoro. 8, 8. So I shouldn't count that way. I should count, this is carbon 1, 2, 3, 4. I should count from right to left. If I count from right to left, on carbon 1, we have 2 fluorines. So this is 1, 1 difluoro. All right. Now, where's the methyl? The methyl is on carbon 2. The methyl is on carbon 3. The methyl is on carbon 3. This methyl is on carbon 3. This methyl's on carbon 3. This methyl's on carbon 2. Are there any other additions? No. So what we have then is 2, 3, 3, 2, 3, 3 trimethyl octane. So this molecule that I drew is 1,1-difluoro 2,3,3 trimethyl octane. Okay. Let me try to clean this off for a bit. Okay. Let's try so you can see it perhaps a little better. Oh, it smells so good. All right. All right, let's see. Wow, let's try to name this. Once again, the first thing we need to do is to find the longest chain of carbons. Okay, you see a C2H5? It's an odd number, so this is ethyl. But it's not ethyl if it's part of my chain. Let's count the chain. 1, 2, 3, 4, 5. Is this pentane? Well, let's see. 4, 5, 6. 4 carbons. 5, 6, 8. There's 2 carbons. Say it again. 4, 5, 6, 7, 8. So this is octane. So what was my chain? 4, 5, 6, 7, 8. So watch, I'm making this dark. This is my chain that I'm counting. Anything not part of my chain is an addition. So what else is there? Chlorine's there. There's a chlorine. Now look, this beast is not part of the chain. What is this beast? It's CH3. What is CH3? It's methyl. Da? So let's see, what do we have? Should I count from here? If I count from here, this would be 4, that would be carbon 5, carbon 6. I don't think so. I think I need to count from here. 1, 2, this would be carbon 3, this would be carbon 4. So on carbon 3, remember this is my chain, on carbon 3 I have chlorine, on carbon 4 I have chlorine. So I have a 3, 4 dichloro. Right? Is that it? There's my chain. There's an addition. There's an addition. This is my chain. Any other additions? Chlorine was an addition. Look, this beast, this stuff was not part of my chain. What was this? This was methyl. Where was the methyl? On carbon 4. So this is a 4 methyl. So this compound is 3,4-dichloro-4-methyl octane. See, it's a puzzle. It's just a little game. We'll do one more. Hopefully the tape will not stop on us, okay? Sometimes the tape gives out, even if I don't give out, okay? Let's see if we can name this. Sorry for the silence, but I actually have to think. Once in a while I need to think. All right, we got to name this beast. Okay, all single bonds. It's an ane. This is an ethyl. That's a hexyl. Right? This is a methyl. But we have to see if they're part of our chain or an addition. So let's see. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 6 is 9. Is that the longest chain? 6, 7, 8, 9. 6, 7, 8. 6, 7, 8. Is that the longest chain? 6, 7, 8. 9, 10. 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. 2, 3, 4, and 6 is 10. This is my longest chain. Gotcha. So this is decane. It's decane. This is my chain. This is not part of my chain. This is not part of my chain. And this is not part of my chain. This is the longest chain. Anything not part of the chain is an addition. So what do we have? Well, again, this is a CH3. So there's a methyl. Here's a methyl. And here's a methyl. So what do we have? Which way should we count? I think if I count here, if I count from here, this is 6 carbons. That would be 7, 8. I think that's the wrong way. I think we have to count from this. 2 carbons, 3 carbons, 4 carbons. So let's see. On carbon 3 is a methyl. On carbon 4 is a methyl. On carbon 4 is another methyl. So this looks like 3, 4, 4 trimethyl. Decane. 2, 3, 4. So decane, 10 is my longest chain. So I would use colored pens or something so I could see my longest chain. Be careful, it's not so obvious what the longest chain is, and it's not so obvious to count left to right or right to left. Okay, I'll try not to be too tricky with you, but we always need to start counting from the side left to right or right to left, the side that gives the lowest number. So instead of 6, 6, 7, we would pick like 1, 1, 2 or something, whatever way to count. Okay, so there's my longest chain. I think counting from here, there's 2 carbons, 3, 4. That's lower than counting counterclockwise. So on carbon 3 is this methyl. On carbon 4 is a methyl, and on carbon 4 is another methyl. So it's 3, 4, 4 trimethyl decane. Wow, isn't this fun? All right, next lecture I will give some more examples. And then I'll give a bunch more examples. Maybe I'll stay with the alkanes a little longer before we do double bonds and triple bonds, the alkenes and alkynes, and they're actually easier than the alkanes, and I'll show you why. And then we'll do the ring structures, such as benzene and those types of things. Okay, so we got a couple more lectures to go, and we're almost done. Go over this, then go over it again, then go over it again, and go over it again. Okay? Next video, I will just do some more examples for the alkanes. Okay? Hopefully we'll catch on. All right, have a great day, have a great night, and see you next time. Be well. Peace out.